5? For number 5?
Not number 5, silly me. Number 2. There it is.
Steven swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Steven's velocity is modeled by v of t equals 2.38 e to the power of negative 0.02 t sine of pi over 56t, where t is measured in seconds and v of t is measured in meters per second. Find all times t in the interval 0 is less than 2, which is less than 90, at which Steven changes directions. Give a reason for your answer.
So the given function is velocity. The position is changing direction when velocity changes sign. So if you want to write on here, when velocity changes sign. And then on your calculator, it's changing sign from 0, meaning positive to negative. What I would do is type in 0 on y1, and then the function in y2. We should all be typing it. Nicholas, go get a calculator. So if you put the equations on y1, y2, or wherever, when we're computing, we don't have to type that in anymore. And when you're ready, I would start at zoom 6. Actually, 50-meter long pool for 90 seconds. I think we should manipulate our graph, our window. Let's make our x max be maybe 120. I want to see at least 90 seconds. So go to window, x max, 120. You can go to zoom 6 and zoom out couple of it, but we might be wasting time. So x max at 120 and simply graph. And our graph should somewhat look like this. And it is changing sign from positive to negative right here, and that is when we are changing directions. So second calc, 5, enter 3 times. And it looks like it's our whole number, x equals 56. Did y'all get 56? Hopefully. Okay, so then let's go ahead and steal the sentence stem. It says, Steven changes direction, and then we want to also mention the interval. Okay, let's write in the interval. Always write more than you need. 0 to t, less than 90. Steven changes direction. At what time?
56.
Okay, at t equals 56 seconds. And that is because his velocity did what? What was it? Change his sign. It doesn't have to be positive to negative, because if it's vice versa, he is still changing direction. So change his sign works too. Now, if he did say positive to negative, am I going to take off? Because positive to negative is still changing sign. So all that with the answer included is 2 points. So go ahead and do a self-check. If you were to expose this in the future, if you're going to get it right, put a check mark. Okay, let's go to part B. Nathan, go ahead and read part B.
Find Steven's acceleration at time t equals 60 seconds. Show the setup for your calculations and indicate units of measure. Is Steven speeding up or slowing down at time t equals 60 seconds? Give a reason for your answer.
So acceleration, and if I were to go back to my PVA, if I derive the velocity, that is the acceleration, so a of t is equivalent to v prime of t. And we have to mention that to tell the graders, hey, I know what the velocity and acceleration relationship is. So on this one, let's go ahead and write out a of t, and in this case, our t was 60, is equal to v prime of 60, is equal to So to find the derivative, it was math what? Math number 8 or 9? 8? And I'm gonna do a little shortcut on this one. You can go to the home screen and do the following. Go to math 8, dx, and in our function, I have it on y2. Do y'all know how to recall the y2s? Okay, write this out. Vars, function, y2. So go to vars. Vars is like underneath the arrow. Oh, y bars, my bad, vars, y bars, and then function, select y2. So it's gonna basically plug in the y2, whatever's saved on there, without us plugging it in every single time. And then our value of the x was 60. And that should calculate our acceleration. So let's round this to negative 0.036. Did y'all get to it? Vars, y bars? It's kind of convenient. Now, if we're talking about speeding up or speeding down, what else do I need to compare this with? Acceleration and what? Uh-oh. Did we all forget? You compare acceleration and velocity. So let's look for velocity at 60. For velocity, since I already have the function on there, go to table set, plug in 60. It's a bunch of calculator tricks today. And then go to second table, and I'm looking at y2 only. So my y2 here, when I hover, it says 0.16. So let's see how the AP graders are gonna look for this. Mentioning that A of 60 is equivalent to V prime of 60 is 1 point. Finding that answer right there is also 1 point. And actually, I forgot the units, because units do matter. It'll be meters per second squared. So let's see why it's meters per second squared. If the given velocity was meters per second squared, meters per second, deriving that one more time means I have 2 of these. Good? Okay? So we must have the units. And then, let's kind of steal the sentence stem. On our sentence stem, I'm gonna say Stevens accelerate, or I'm just gonna say he is speeding up at t something of this nature. Speeding up. We have to mention the time. Okay. So let's see if we can put them all together. Let's put on here, Steven is speeding up. Why is Steven speeding up? How do I know? What are these two signs? If acceleration and velocity are the same, what happens? It goes up. If they're different, it goes down. So it's speeding up at t equals 60 seconds because his velocity and acceleration have the same sign. The same sign. And that will give us another point. So go ahead and put a check next to the one that you might potentially get right. And grade yourself as we go. Kira, go ahead and read part C.
Find the distance between Stephen's position at time t equals 1 seconds and his position at time t equals 80 seconds. Show the setup for your calculation.
Okay, so we're looking at position. If I know the velocity, to find the position, I have to integrate. Is that right? Because we're going backwards. So let's go ahead and put on here. And I want to also underline what I'm going to write out. The distance, blah, blah, blah. And then we're going to end it with is whatever that number might be. So for number or part C, it says distance from 20 to 80 of v of t dt. And let's use that trick again on the home screen. Go to your home screen, do math 9. And when I say 20 to 80, And let's call out the vars, y vars, function, y2 of dx. Nathan, what'd you get?
23.38.
Ooh, I got something else. Oh, there it is. Took a while. 23.384 meters. So, knowing that the position is the integral of the velocity is 1 point. And then let's write out the whole sentence then. So let's write distance between Stevens. Did I spell Steven with a V a while ago? I did. Oh well. Stevens' position at time t equals 20 seconds and t equals 80 seconds is 23.384 meters. And that's going to give us another point. So go ahead and grade yourself. Put a check if you're going to get it right next time you see it again. Okay, the last one. Sophia, go ahead and read part D.
The final total distance Stephen swims over the time interval 0 is less than or equal to t is less than or equal to 90 seconds. Show the setup for your calculations.
So total distance is always the absolute value of who? We've done this like 3 other times. Of the velocity. So write that down somewhere. So we know we have the absolute value, and we're starting from 0 to 90 of the absolute value of v of t dt. And let's see if we remember where the absolute value was. Okay, go to math 9, and we're going from 0 to 90. You find the absolute value from here. You go to math, and you go to numeric, and then the absolute value. Let's do the vars thing again. Vars, y vars, function, y2 of dx. Oops, not there. Dx. It might take a while to calculate almost any integrals if it's a big range. The other one was pretty fast. Let the circle on the top right-hand corner think. Did y'all get 62-ish? Okay. I'm going to say 62.164, and that's in meters. So knowing that the total distance is the absolute value of the velocity is 1 point, and you must also include the upper and lower bound. And then, did we underline what we were going to say? I'm going to go blah, 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 blah is the answer. So total distance. Stephen swims over, I think I'm just going to write out the interval, not the word interval. That should be forgivable according to the graders. Is 62.164 meters. And that will give us our last point. So again, grade yourself. Make sure that all the points were given. 2, 3, 4, 5, 6, 7, 8, 9. Yes.